Super excited to kick off another Tandy assembly. So when they started asking for tech talks, I was like, what do I know nothing about that I'd like to learn about? And I was thinking CP/M because I've used multi-DOS and Tris-DOS and LDOS. So I kind of dug into this. So if you're a CP/M expert, this is probably not going to be too educational, but if you're kind of new to it, and a lot of us in the TRS-80 community are, this will be kind of exciting. Also on the link here, if you take a picture, that's the URL, and it'll have all of the slides and everything I'm sort of showing, so you can get it all on GitHub if you're interested in playing around with this. So I'll talk about the history a little bit. This is definitely not going to be a history lesson. You know, there's lots of good CP/M's history. There's the fables and things like that that are out there in the history of personal computers with CP/M, but I'll talk about it a little bit. We'll then kind of dig right in with a demo of kind of built-in commands to CP/M. And I'm going to talk a little bit about the keyboards, because when we get to the TRS-80, keyboards are a little bit odd and why that happened in CP/M. Then kind of the TRS-80 arrives, so we'll switch over to like what was there for CP/M on the Model 1 and the Model 3. Probably not an exhaustive list, but I've tried to gather what I could figure out and what I've been able to try out. Then we'll talk a little bit about what PIP is and CP/M device mapping, which I find kind of fascinating. Kind of my own history was I did a lot of work on DEC mini computers in the 70s. And you can really see the history of CP/M coming out of Digital's operating systems on the PDP-10 and PDP-11. So that it was really natural to me. Then we'll talk a bit on CP/M on the Model 2. And then we'll do some assembly vibe coding, because you know AI is kind of the new thing. So we'll try that out and see how that goes. And then CP/M on the Model 4. And then a little bit, I got a short thing, which I still don't think is the best way, but like what I figured out how to transfer software to CP/M. There's a lot of good archives out there for CP/M. If you're trying to run them on Tandys, you know, there's ways to transfer the software over with some final thoughts. So one history in one slide. So in 1972, Gary Kildall was teaching at the Naval Postgraduate School, which is a really nice place if you've never been there, by the way. It's on Monterey, California. And Intel gave him one of these at the top, the Intellect 8. He also had a like prototype ShoeGuard 8-inch floppy, and I am totally guessing he had one of these. I'll talk about why, but I'm pretty sure this is what he was using. So this was kind of what the genesis of CP/M was. So he built it, and in '74 he offered CP/M, and he also had a programming language called Programming Language for Microcomputers. CP/M is Control Program for Microcomputers. Intel didn't buy it, so they left it with Gary Kildall, because I think they thought nobody would be using these for disk systems, but they did buy the programming language. So in the late 70s, I'm kind of saying dominates, but this was the golden era of CP/M. You had a lot of systems, and they weren't called Tandy. They were called like Altair 8080, the IMSI. There were companies like Krememco. It was the era of you had the box, probably with lights and switches, and you had a terminal. So this picture at the bottom, which is an Altair Arduino, it's not a real one, but the ADM3A is one. This is the kind of setup they would have. Or a lot of people would have had the ASR33. This would have been very common. So in the early 80s, CP/M kind of fades a bit. The IBM's PC, when it came out, Microsoft DOS was free, and there was an upcharge to get CP/M, so you can imagine how that worked out. Companies like Tandy and Apple, as the kind of not kit world came into play, they used their own operating systems, and so it kind of faded into obscurity. But it's still a really interesting bit of history on the computers, and definitely did touch the TRS-80. So one of the things I wanted to mention that I did not know was the versions I'm going to talk the most about and that you'll see in the demos are version 1 and version 2 of CP/M. 2 is the most common. These are kind of some of the differences, but the biggie is version 1 CP/M just handles floppies. whereas version 2 usually supports hard disks and floppy disks. So a lot more flexibility in the version 2. Some of the commands are a little bit better, and an interesting feature that they added, which I don't know how widely it was used, but you could have like multiple user areas on the disk, and you could have like, you could go in and say you're user 1 and someone else could say they're user 2, which is like right out of the DEC era, you know, your user 1, 2 or something in those days. So later versions like CP/M3 are pretty uncommon on the TRS-80. There were some versions. So these are the built-in CP/M commands. Little bit unnatural if you're used to like TRS-DOS. So I wanted to start off kind of showing these off with a demo on the Model 4. Again, you don't have to worry about all the command lines I'm using and things. Let's see how this works. Hopefully you can sort of see what's going on. So this is a Model 4 with 128K. And one of the interesting things about Montezuma is if you have 128K, it uses 64K for CP/M and makes a memory drive M with the other 64K. So if you've wanted something to do with your 128K Model 4, run Montezuma CP/M. So the dir command works as expected, and we see some files. This is great. We also see this is a CP/M version 2.2 at the top. So let's make a new, I've got this tim.txt file. So let's type tim.txt. What does that do? So the type command just sort of puts out to the console what you're seeing. So let's get rid of that. That's not a very good message. So we'll use the ERA command, which is the delete command. Erase is what you can kind of think of. So this will get rid of the file. So, all right, we haven't got it, so let's create a new one. So I'm going to use a program called the ED, which we will definitely not cover here, but I'll cover kind of what you need to know. So you need to put a name. So we'll say tim.txt, and it'll notice it's a new file, so that's good. And to insert file into it, I use the I command, and I'll put and then I have to type Control-Z to end the input, and then I say E, and it will write this out to the file. So we'll do type tim.txt, and there we go. And oh, you know, tim.txt, since we now have a welcome message to Tandy assembly, let's get that thing. So we'll rename it with our rename. And this is what's a little bit weird. We'll call it welcome.txt. And what you say is tim.txt. So it's a little bit odd compared to Unix and modern DOS. The target of the rename is on the left-hand side, and where you're getting it from is in the right-hand side. And they use this equals, so it's a little bit like a math equation, not like what you're used to in Unix or DOS or something. So we'll go ahead and do that. And now we can, hopefully we'll see a welcome file. Yep, there it is up on the second thing, but you could also say dir welcome .star, and let's see, it'll print the file out. Oh, and let's do that again. We can go to that, remember I told you we had that memory drive, so that's great. We'll go over to M, and there shouldn't be any files, yep. So let's do ed tim.txt. We'll add my old file back. Oh, what's wrong there? There's no path going on here. So the problem is the ed command's on the A drive, and I'm on the M drive. So I'm going to say a:/ed tim.txt. Okay, so we'll do this, and I'll insert and say Tim was here. We Control-Z and then E, and we're good to go. And in fact, tim.txt in the back, it makes a backup, which should be empty because there was nothing in the file, and should have my Tim was here. Now, one interesting thing, and I'll use a little bit of the TRS-80 GP thing. If I reboot, let's go back to M: and do dir. Oh, it's gone. So don't forget it's a memory drive. If you reboot, everything's going to be gone. So it's really fast and works great, but it won't be there. And one thing I do want to mention is we're going to talk about this, but one thing that you use a lot, I use Control-Z to end the file, but Control-C is actually a warm boot. And what this does is reloads the command processor and gives you another prompt. So you can type Control-Z, C at pretty much any time. All right. back to the slides. And we're slowly going back to the slides. There we go. All right. So to use CPM, you really need a control key. This is a Gen AI image here, so I asked it to make a really big control key. Warm boot, which is what I just demonstrated, is Control C. The end of the text entry, which you saw, is Control Z. If you want to send things to the printer while you're seeing it on the console, you type Control P as sort of a toggle. It'll start echoing to the printer. You turn the toggle off. And there's a whole bunch of command line control characters. Control U, which would be like Unix, or Control X deletes the line. Control R retypes your current line. So if you're using something and it's not working right, you can take Control R and it'll show you what you typed. So before you hit return or enter, you can see what it is. Control E goes to the next line. So if you're on a terminal where it goes out to the 80th character and then just starts pumping at the 80th character everything you type, you can't see what's going on. You can type Control E and it'll send a carriage return line feed, but won't actually execute the command or include that in the buffer, and you can continue typing. So there's a lot of kind of nice things with control characters. So where did this come from? And this is where it came from. This is a picture of the teletype. You can see what the keyboard looks like here. So at the up in the second row on the left, you can see the control key. Some of the other characters are going to be interesting is if they had clearly no thought about doing anything with lowercase characters, because you see things, if you look at the M key and the K key, that's where the braces are. You'd had Shift M, Shift K. The other thing you'll see in a lot of the device things we show later is notice that paper tape punch. This is an ASR33. This is where the punch and the PUN and the RDR device are coming from. The one is like writing to the punch, one is reading from it. This terminal was really like used a lot, and one of the things accidentally it had that was really, really helpful in early computers was this was one of the first ones that supported a new emerging standard for characters called ASCII. And before that, it would have been Baudot, would have been what these teletypes used, but this one supported ASCII and was very popular in early computing. You'll oftentimes see pictures of like early Unix with that sort of thing. So we've had a little bit about CPM and shown it off a bit. Let's now the TRS-80 comes into play, and we got Gen AI going again, and I will give the warning that Gen AI might not accurately portray historical computing events. So I asked it to show a happy users for an Altair and an ASR33. So that's interesting. And then the TRS-80 arrives and scares them. So this was interesting, but just kind of a bit of fun with the new AI world. So going into this, we need a little more technical background. So if you're not super technical, this may be a little bit scary. But this is what CPM sort of expects on the Altair and all these other computers. You have a little reserved area of 256 bytes at the beginning, and the program memory begins at hex 100. So you got a whole bunch of program available. Then the console command processor is there. This is the thing that's allowing you to type and handling when you hit return to get things going. The basic disk operating system is above that. This is the same across the CPMs. So this is all portable. Then there's the non-portable part. The BIOS is at the very top of memory. Now, if you didn't have 64K, then there's commands to remove, like shift this upper part around in memory depending on how many K you have. So this is sort of how this supported all these different hobby hardware things. You would basically follow this layout, adjust the amount of memory you had, and you had to, the company, whoever it was, like if it was Altair or Kermemco, they would write a BIOS for their particular hardware and make sure it was well supported and that sort of thing. So on the TRS-80, this was a problem. By the way, these dollar signs mean hex, not the amount of money you had to pay for RAM. Which I could see how you might get confused, but that was the situation. So good. RAM started at hex 4200 in a Model 1, or at least usable for a program. So below that is the level 2 ROM, keyboard video memory mapping, the video memory mapping, and some other minor things. Another problem was the keyboard looks nothing like an ASR33. There's no control key, which is probably the biggest problem, and then there's no brackets whatsoever. So this was a big problem. Tandy was writing TRS-DOS. We know the history of that. Randy Cook did this, and that spawned a bunch of descendants. And for most users, this was fine. So the TRS-DOS and descendants was fine on the Model 1. However, TRS-80 users overlapped with CP/M users. Probably you could think of it as there was a group that had the hobby computer world, and then the TRS-80 expanded, so there was some of those folks, and then there was a big, new pie created. But there were users that wanted CP/M. A lot of times I run programs like WordStar and other things. And definitely one point of data about this was on the Apple II, which came out the same year as the Model 1, Microsoft actually produced a CP/M board. There's a Microsoft board that has a Z80 in it that runs CP/M on the Apple II. And this thing was a major source of revenue for Microsoft in 1980. In fact, some accounts of it say this was what kept the company afloat in some kind of tough times, at least for that period of time. TRS-80 had a Z80, so this was easier. At least it wasn't like we had to put a whole thing in it to make it run a different processor. But because of this memory layout issue in the keyboard, it was in some ways harder. So this is what I've found for the Model 1 and the Model 3. I have not tried all of these, but many of them I have played around with. I have not gotten anything to work on a Model 3 to date. There's some interesting articles, and I think someone has a demo here. Mike, I don't know. So we'll see. There's some work being done in the community. However, there's kind of two different flavors of CP/M on the Model 1. These top three are what I'll call they remap CP/M. So they move they leave the computer as is and move programs starting in $100 or hex 100 to hex 4200. So this means you need special software on these systems. You either need to rebuild it yourself or you need to get it from somebody that's doing it. On most of these, they use control as the down arrow shift, which is way easier to do on a real Model 1 than it is on this MacBook, so I'll probably be having trouble with that. The other thing they did is they remapped the braces to the greater than sign and the less than sign on the Model 1. So there's another flavor, which I actually have run on a Model 1, which is the Omicron variety, which needs a mapper board, the Omicron mapper. Mav has a Mappa 1 board. That's what I have, a modern redo of it. And it actually runs starting at $100. So it has special hardware to allow it to boot up, and I'll show you that. So this could, in theory, run standard CP/M software, but you have to modify your Model 1. On the Model 1 and 3, there was a Holmes Vid80 expansion. And then there's some other ones. I don't know a lot about the shuffleboard things, but there's kind of some articles in the magazines about this. So going back into a little bit more demos, we want to talk about what the heck is pip. So if you kind of put a mental thing that pip equals copy, you won't be far off. But this was pretty much lifted right off the DEC OSs of the 70s. But it's very weird if you're used to DOS. So it stands for Peripheral Interchange Command. And you can do some things with it. Again, it has this weird equals notation where the left-hand side ends up going into this. But if you notice in my first demo, the built-in commands, I did not do any copying. This allows you to do copying. So this will copy the tim.txt file into the tim2.txt file. So I can do one command at a time. Or you can just run pip and you get a new kind of prompt, and you can do as many of these things as you want, and then you just hit return when you're done, and it goes back to like the A prompt like that. So pip is more versatile than copy, and we're going to show that off a little bit. It's definitely not just a simple DOS copy. So you can also use the wildcards of stars, so like tim.star, or a question mark to replace one character in these commands. So it's a little bit more flexible. So I also had GenAI generate devices for, these are the 4 CP/M devices, and we'll show these off a bit. So you have Con, the console. It actually did pretty good on all of them. RDR is probably, there were not a lot of people with CP/M machines using 3.5-inch floppies on as their reader device. They were using ASR33s with punch cards. But the punch one got it right, and then list is sort of a printer, so that's nice. So I just wanted to show what these are because one of the things that fascinates me is kind of device redirection in these early operating systems, and so we'll play around with this a bit, but CP/M sort of had all of these sort of in it. So let's go to my demo 2. All right, and what I'm running here is, this is a little more bit tricky, so hang with me. We've got two things happening here. So I'll expand these so you don't have to read these yet. But I have a Model 1, emulated Model Run running Lifeboat, which is one of the remap CP/Ms. And I have connected to it, let's just assume it's a serial line, a DT1 terminal. So we're going to focus mostly on the, let's go to the Model 1 to begin with. So the first command that's of interest is, we haven't messed with yet, is the stat command. And what it's mostly used for is to show me the space available on things. So I've got a couple of disks in here, dir B. All right, so Microsoft Basics on disk B, and if I do dir A, I can see the operating system on disk 1. And if I do the stat command, every disk it knows about, it'll show me how much free space is on there. But it also has some tricks with these devices I just sort of showed you in the slide. So let's say stat, let's see what the devices are. So this is telling me that the console is connected to the TRS device, which for this is the TRS-80 console. Reader and PUN aren't really supported by Lifeboat, but the list is set up to LPT PT1. So let's give that a go. We showed pip before, so let's do a pip. We'll go to the LST device, to the printer, and we'll send in, I wrote a little program on this, which I'll talk about in a minute, an assembly language program, but it's just an assembly language program, and we'll send that to the printer. Hang on, did it die here? Nope, there we go. All right, so let's show the printer, and you can see the output coming out. And here's my assembly language. So it went to the printer. So that's great. End, and we'll get rid of our printer. And we will take a look. One of the things it does have is there's another stat command, the val, that you can look at to see what the options are on these devices. So these are the remapping options. So you can see I've got the TRS console. I can actually remap, and the one I'm the most interested in is the RS-232 for the console, or for the list device. So let's go ahead and do that. We will reassign it. So we're going to say stat LST equals R32. And we can do a stat dev to see if that took. Great, looks good. However, there's a problem with Lifeboat. This assumes in your Model 1 there is a serial card, and it has a whole bunch of switches for like baud rate and stuff, which nobody really used, but they assumed you would. So they assumed like if you need to change from 300 to 1200 baud, you would take your monitor off, unscrew the thing, and go into your thing and flip the switches. So I found that annoying. So I actually wrote a program. So we'll use my program, R32 baud, to set the baud rate to 1200 on the serial board before we start doing stuff with it, and this will do it. So this sets the device. Now we can give it a try. So let's do stat LST colon equals R32 baud ASM. We'll send the same file to the thing. So now we're interested in the terminal. Whoops, what happened here? Oh, sorry, I need to run pip, not stat. Whoops, my bad. I can't believe I've not made more mistakes like that so far. All right, so we'll start sending the file over through the list device just like we did to the printer. And what will happen is you'll start to see the, it's a little slower than the printer, which is instantaneous in George and Peter's implementation. But there we go. It's going up to the printer. So that's the assembly language I wrote to do this. All right. It's nearly done. So we'll give it a second. All right. However, we can take this a little bit farther. We can actually remap the console. So let's look at the options here. So let's remap the console to equals R32. So we're going to remap the console to R32. Now what's going to happen is this is going to hang, but if I go over to that terminal, I now have an A prompt. So now I'm running CPM on the terminal. So this would have been very natural to people that came out of the kit era, but to TRS-80 users, or like this is a little bit odd. But this is reasonably well supported. All right, on DT1. Yep, and oh, and then when I'm done, I can just stat console back to TRS-80. All right, and now that hangs, but if I go back here, I'm back in business. All right, so fun with device mapping. All right, and like if you're having trouble visualizing this, like because it's all like Windows on a MacBook, this is what this really looked like. So with a mapper board running Lifeboat, there's my Model 1. You can see I said statcon equals R32, and that's an ADM3A terminal, a real one, running what I just did in the DT1. So this is with a real serial connection between the computer. So all of this stuff I'm doing, I pretty much did it on real hardware, which was fun because then I'd figure out how to do it in George's emulator. But it all works. So this is kind of like just if you're more concretely focused in the old computers, this is what's going on. All right, good. Next. So one thing that's really interesting about the older CPMs is actually making a backup disk is kind of tricky. So I wanted to show this on Lifeboat, which is one of the 1.0 CPMs. The recipe was to format the disk, which is completely non-standard in all of the CPM and 2s and 1s. So you have to go figure out for your CPM even what command it is. But on Lifeboat, it's actually called format, so that's nice. If you're used to like backup, it's going to be a little bit of a rough road. Once you have a formatted disk, you then use a sysgen, which will write the CPM operating system into the right place on your disk. Then you have a bootable disk, but there's nothing on it. So it'll have those built-in commands we showed, like dir and things like that, ERA, rename. But to get the rest of the stuff, you need to do a pip command. So we do that. We're going to copy everything from A, where our original disk was, to B, where we'll format it. And we have to do some options, which on most CPMs would be this bracket notation. But on the Model 1, because it doesn't have brackets, they use, excuse me, they use the greater than, less than. Now the two options I'm playing with here are, one, to do copies for object files, so ignore file endings for text files, and V, verify the copy after it's done. You could probably skip this on the emulator. So let's go back and give this a quick go. All right. So we start with a format. Wait, what's going on? Yes, format. All right, so we are going to format drive B and hit enter. Whoop, there we go. All right, we don't need another one, so we'll try to get out of this. Takes a few times with the break key, and we're back at the prompt. So now we have a formatted disk in B, but it doesn't have the operating system. So for that, we use sysgen. And that should ask us, it's going to where the heck is the operating system? So for that, we're going to tell it A, so it can read it in. Whoops. All right, now we got to tell it where we're going to put it, and B is where we're going to go, and now we're going to put it into B. All right, so enter to reboot. Now before I go any further, let's kind of show that off. So cat demo 2A, sorry. I forgot to like prep this up, PB copy. Then we'll just paste, and we'll actually modify this so that it's actually booting from the disk we just created. If some of you are good with TRS-80 GP, you'll know what I'm doing. Otherwise, I'll have all this stuff. So basically what I'm saying is boot a Model 1 with that blank HFE that I just formatted as disk 0. So this should boot up. And in fact, we've got a lifeboat with a system in it, but if I do a dir, there's absolutely nothing on this disk. So that's kind of the situation. So let's go back to what we were running before. We'll fire it back up with the 2 disks, or with my original one. All right, which make sure we're at the right one. Yep, and then we would do pip, B colon equals A colon star dot star, and then O, sorry, OV. All right, and this will start through. And this will take a while, but it'll move everything over. Then you've pretty much got a backup of your boot disk in Lifeboat. This is making you appreciate Tristos, I imagine. So I will not make you sit through that, because that'll go on for 5 minutes. Okay, very good. All right, so now let's talk a little bit about what the heck happened. Like, it was quickly apparent that rewriting all the CPM software was a giant annoying thing, having to move the beginning of memory for the TRS-80. So the Omicron mapper came out, and here's a picture of a real Omicron mapper. Basically what this thing is you pull out your Z80, and you can see the empty, you can see the empty socket here. That's where the Z80 went, and at the bottom there's pins, and you plugged it into your Z80. So my Model 1 has a MAPA 1, which is MAV's modern reproduction, which is a little bit different than this, but it does the same thing. And this is very well supported by TRS-80 GP. So I put the recipe there, M1-Omicron, and you get an Omicron mapper. So the advantage is way more CPM software runs. I'm not going to tell you everything is 100% working, because some software would have assumed the terminal had 80 characters, and this Model 1 only had 64. There could be other problems. But the software is assuming hex 100 as the start of its program, and it's going to work more naturally with this. So let's quickly show that off. This one here. All right, so this is what you get. When you boot it up, like on my Model 1, I get this. So let me kind of show off. This is kind of where it's going to decide whether to remap. So if I pick CPM, it will remap. If I pick TRS-80, it will not remap. It'll just boot your normal disk. And I don't have a boot disk for TRS-80, but I definitely can do one of the things that threw me for a loop is, how do I get into BASIC? Well, what you do is you hold down the break key and press T. And then it will, so it's sort of like reset break, but I have to wait till that comes up and press T, so that messed me up. But then basically I'm in memory there. So let me reboot. I'll reset the machine. Okay, perfect. And let's boot into Omicron. So this is Omicron. One of the things is, like, to do the Control C is that weird down arrow shift. To do the Control C, so that's kind of annoying on this. But while we're in this, let's show off another CPM feature. Suppose I like doing a dir, right? But then I like to see the devices set up, because we just did all those device things, so I want to see what they're pointed to. So you can see that Omicron doesn't have XXX. It supports a little more of this stuff, but that would be cool. It'd be cool if I just had a command that did that. So let's create ls.sub. I'm going to make a submit file, which is an early batch file. So let's put that in. I'm going to do dir, then I'm going to do stat dev. Then I'll type Control Z. Whoops, but I have to use the weird up arrow shift thing. Okay, and then E. All right. So that ls.sub is there. So let's type. Does it look okay to us before we muck with it? All right, then the submit, the CPM submit command, ls, will now let me run kind of this is like an early batch file. It just kind of sends each of these things to the command processor. slowly. But it does work. So a little bit of an early batch system. You can see where kind of batch files might have come from the CPM world. All right, back to the slides. Good. All right. So got a little bit of a flavor. That's what a remapped Model 1 looks like. So if you have a map, if you actually have a real Omicron board, that's awesome. But also, like, you can either cook up your own or get one from MAV. So all right, CPM was also very popular on the Model 2. And this is my Model 2 running Pickles and Trout CPM, kind of showing off one of the features it's famous for. It has a lot of menu-driven stuff. So if you don't know the CPM commands, if you're not a CPM hacker, this is a very nice environment because it'll help you prompt through and that sort of thing. If you are like love the CPM command line, this is probably just annoying. So your mileage will vary which you like. So on the Model 2, Pickles and Trout is really nice. The keyboard is really good for this. It has the control key. The one thing it's missing is the bracket. Oh, sorry, this is actually incorrect. It does not miss that. It has all of them. Scratch the line. I will correct my slide. So it has all of the keys you need for CPM on the Model 2. So Pickles and Trout CPM is kind of like the de facto Model 2 CPM. So like I said, though, it's very menu driven and things. We'll see it. Lifeboat we saw on the Model 1. That was the first demo I ran. Lifeboat was a very popular CPM vendor. They supported all kinds of computers, including the TRS-80. So if you're more like, I don't want all the menu driven stuff, Lifeboat is a good option on the thing. So there's Anton's. Is similar. I played around with that a little bit. It looks good, but it doesn't support hard disks like the other two do. CPM Plus is something Tandy rebadged from Digital Research, and it supported a whole bunch of stuff. I didn't play with this too much, but it's a CPM 3, so it's really weird. A lot of the commands are changed and things. It almost has a little bit of a feel like it's a totally different operating system. And that sort of thing. And I want to reference most of this I got from Peter Satinsky's definitive list of the TRS-80 Model 2 operating systems. So, but I did play with mostly Pickles and Trout and Lifeboat. So let's do something on the Model 2. So we're in 2026 here, so we don't have to write assembly language anymore. We got LLMs to write assembly language. So I got into Gemini and was like, write me an assembly language program for CPM 2.2 that prints welcome to Tandy Assembly 2025. So it definitely could do that, it says. So it printed out this, which was mostly right. So I had to work a little bit. But I wanted to show, this is from the Programmer CPM Handbook, like what's actually going on inside an assembly language program when it calls into the operating system. So what happens is, if I want to do a CPM request, like print a line to the console, I call 5 after I've set up some stuff in registers, and that goes down into the low part of memory, literally memory location hex 5 here, which causes it to jump to BDOS to go into the right place in the basic disk operating system, which then handles, whenever it needs the BIOS, it does. So you generally are interacting with the BDOS, this middle section here. Your program, whoops, that was bad. Your program makes a call, which then goes into BDOS, does stuff, and maybe calls the BIOS, and then it returns. Now, what happens at the end is you actually call jump 0, and that goes into BDOS and reloads this. The reason it does that is it's kind of a nice design thing, but this was really in some memory-constrained environments in the early days. So when you start your own program, you don't need this anymore. This is the thing that handles the command line and the prompting and all of that. So this is like extraneous. So your program can actually use memory all the way up to this BDOS line. So this goes away. So when you call jump 0, it goes back into the BDOS and it will actually reload this from the disk back into its right place in memory, then do the prompt. So that's kind of what's going on when you're running programs. So let's talk about how you would do this. Now, I'm really not excited about ed. It's pretty tough to deal with, and I'm definitely not going to go into that in this talk. There's whole chapters of books about this, and you can watch it online. But it's pretty complex, but you can get away with a simple little recipe here. So get a new file, edit, like your file name.asm, hit I, paste your text into TRS-80 GP, type Control-Z, and then hit E. Your file is on the disk. So the next time you do an update, you update it in Visual Studio Code, type ERA, the file name or whatever, .asm, then do the same thing again, and this works pretty well. So then the next command, once you have an assembly language file, will run as ASM, which creates two files, a hex file and a print file. I'll show you those. But it doesn't, interestingly, create something you can run. The hex file is a representation of what you'd run, but it's text. Then you use the load file to go from hex to a com file. And the com file is what you can actually type the name and run the command. pip.com and these other programs that are in CP/M are just the same as doing this. So let's actually play around with this with pickles and trout. So I'll get it going. I think I have Visual Studio Code. Uh-oh, that's not good. Where did my program go? Hang on. Ah, there's my program. Yay, we now have epic demo failure. Good, so let's go into here. And this is the pickles and trout one, so let's get that going. All right, so as I mentioned, here's the menu. So this is kind of fun if you don't know much about CP/M, but we're just going to get out of that. That's kind of annoying. So let's do a dir. And let's go ahead and start our experience. So let's let's see if we have I don't know whether the welcome program is there. Okay, so I don't have it, so let's do ed welcome.asm. Okay, so I'm going to go into Visual Studio Code, and this is my 8080 assembly code. So I'm going to copy that, go back to TRS-80 GP, I'll do I, and then paste, hit return, Control-Z, E, now we're good. So to actually, I mentioned this, but let's do ASM welcome. It assumes the .asm extension, so we're going to call the assembler. Good. Then we're going to go ahead and load. Oh, wait a sec. Why don't I show you what came out of it? Dir welcome .star. So as I said, we've got the PRN and the hex file. So type PRN. This is your usual assembly language output. You're going to see the program over on the right-hand side, and then you'll see the machine output over on the left. Dir welcome, or sorry, type. .hex. This is the Intel hex format, and it actually just kind of has the representation in text. And then to get it into we'll load welcome. And it actually creates the com file. So we should see a welcome.com, which we can run. And it should say, welcome to Tandy assembly. Yes. Yeah, that's not super impressive. So what I want to show is one interesting thing here is you can really see the soft reboot. So when I hit it, watch, it'll print the line and then it just hangs. And if you were here, you would actually hear that. If you were on a real system, the disk would get accessed because it's loading back in the command processor. So watch, boom, and we wait a while, and on here it's going dit. So in this small of a program, we are not actually needing to do this warm reboot. I'm using a ridiculously tiny amount of memory. So that jump to 0, I can just do a return. So I'm going to do that. and then I'll copy it over here. So let's this give you a sense of like if you're working on something, what you end up doing a lot. So let's copy this, go back to the thing, and we'll call this like ed. Because it's going to be short, we'll just call it hi.asm. So hopefully it's going to be faster. And then Control Z, and you can see I changed it out with a return. Whoops. Here we go. Write the file. Oops. All right. Load it. I guess it would be a useful use of the submit function to put those two together. I didn't think of that until just now, but probably CPM people are kicking. So if I run hi, what will happen is it takes a little while to start up, but once it prints the string, it returns instantly. So you can really see the difference, like here's hi. When it writes versus welcome. Hang, prompt. So if your program's small enough, doing the warm reboot can save you a little. Just a little bit of a demo of kind of an interesting area of CPM. There's also an interesting program called dump, which will take your COM file and print out the hex version of it, which should look similar to the hex output hi.hex. That we got out of the compiler. And in fact, it's a little bit difficult because the format's different, but this is actually correct. It's kind of like, this is showing you 0, 0, but in fact, in the hex format, it's going, oh, I'm going to load it at hex 100. Then you can start to see the bytes line up and things like that. So, great. All right, we're almost out of time, but we're nearly done, so it's working out pretty well. All right, so on the Model 4, I already showed off Montezuma. It's a pretty nice CPM. Model 4 does not have braces. For some reason, they did not go with, on CPMs for the Model 4, they didn't go with the greater than, less than thing the Model 1 folks did. They use shift control, open paren, shift control, close paren, and that's how you get braces in the keyboard. So a lot of these CPMs, it's sort of like we're back to that ASR 33 and they really want that weird keyboard, or not weird, I guess that was the standard. So you sort of got to have things. The nice thing about that I already mentioned is the memory disk. In fact, if you have a Model 4 and you want to know if it has 128 meg memory, boot up this and if it says mem disk enabled, you have 128K, so you don't have to muck around with it. It's really good. And then, of course, there is CPM Plus, which I ran. That's the CPM 3. I did not do too much with this, but this is the Tandy rebadged version of that. So kind of wrapping up, I won't actually demo this, but this is one way to get CPM software over, which we can kind of understand based on what we've shown. So if you find like things in a CPM archive, realize they're probably not going to work without a remapped Model 1. So like on Omicron, you might be able to get them to run, but you're not going to be able to get them to run on Lifeboat on the Model 1 because the software is likely assuming $100 as the start of program memory. Another trick to this is getting software over to a CPM machine is CPM uses the carriage return line feed ending like DOS. That's probably where it came from in DOS. So if you're using Unix or Mac, you really need like DOS to Unix command or something to get that text file in order. And in fact, if you're moving stuff over, you want to like, there's an option to pip that will actually echo it to the console when you want to use that. And if the thing is just writing on the same line over and over again, that's a symptom that you haven't got the line endings right. It should actually go down and print more lines and scroll up. So the idea was hex format is text, but COM is binary. So we can use pip really easily to transfer through the RDR device. Text works really great. Binary has some problems. So if you convert your COM file to hex, the Intel hex, which I wrote a little C program, which is on that site I did there, which I'm sure there's like thousands of these on the internet. It will convert the COM file to hex. Then I split it into several files, and for each one, I did this pip B1 reader, and in fact, this is not quite correct. You want E on the, oops, I should mention this. This was the, I just told you the echo to the console, the E is the echo to the console. So it'll read in the, into B1.text from RDR and echo to the console. So then, once you have a bunch of them, you can concatenate them together with pip. It's very powerful. So I can just say mbasic.hex equals b1.text comma b2.text, b3.text. Oh, there's another error. Let's fix that. Live updates dot. So, all right, great. And then you load mbasic, which we already saw, that converts the hex file to a COM file, and you can run mbasic. And I'll skip the demo of showing you that this works. Just trust me that I got mbasic working. And I tried this on Montezuma Model 4 and the Pickles Trout Model 2 and transferred it with serial lines, and it worked just fine. And like 5.1 of Microsoft Basic from Archive worked great. So finally, let's give the Gen AI another chance. This was what it envisioned the Tandy assembly learning about CPM would look like. So very crowded, and apparently a lot of computers that I have no idea what they are. So, but everybody's very interested in CPM, so I hope you are too. So final thoughts. I think CPM, I learned a lot as an alternate operating system on the TRS-80, at least on the Z80 side. Cocoa people, it's not good. There is a CPM emulator on OS 9. So you can live happy in the fact that at least on the Cocoa 3 you're so powerful that you can just emulate this stuff. You don't even need to have a real chip in there. It'll work great. And that's in the Cocoa archive, Color Computer archive, and you can see on YouTube some people kind of playing around with that. So there's a few videos on it. So recommendations. If you have a Model 4, the Montezuma CPM is really, really nice. So it uses the 128K for the MEM device. It's a pretty, and the Model 4 in general is a really nice CPM machine. It's reliable, it doesn't have any weird memory mapping, and it has good Fred support, which supports at least Montezuma CPM. So it's a really nice computer. It's a really nice CPM computer. The Model 2 is also a very nice CPM computer, and if you're using TRS-80 GP, it's a fine alternative. Or if you happen to have a working Model 2, which is probably far less likely than a working Model 4, knowing what I know, has a nice polished menu-driven interface. Model 2 has no keyboard oddities, which is super nice, but you gotta have a working Model 2. And it has good Fred for 8 support, so that works fine. I've done a lot with that. Hard disk stuff can be done. Model 1, not for beginners. I probably sunk a ton of time into this. All the CPMs require time and effort. You really need to read the documentation, or even the most basic stuff you can't get it to do because like the keyboard doesn't work. You really have to know this stuff. Not all of them are well documented. I've still been searching documentation and unassembling stuff, trying to figure out what it's doing. Omicron works with TRS-80 GP great, or you can get the Mappa1 software if you really care about like running stock CPM software. So all right, so that's it. I'll take a minute. I guess we got at least a minute for questions in our super dupe CPM class here we got going on. Oh, go ahead, Boise.
I want to ask a clarifying question. You said that whenever the binary is loaded at hex 100, the program that you're running, did I understand you right to say that the command interpreter goes away and is reloaded after that other program you run quits?
It can. That was what I was, so when you load your program, you can use all of the memory up to the top of the command interpreter. So the answer is it may go away. So kind of proper CPM etiquette was to do the jump 0, which would call the BDOS to actually reload the command interpreter. Now, if you, like on the little bitty program we did, know that you're not going to overwrite it, then you can just do a return and CPM will just go back to the command interpreter. But I think like most oh sorry, I'm messing up the video. Most programs would call the jump 0. So I just kind of use that as an interesting example. You are correct, you can use all of that up to the memory, so that was a significant advantage when people were like on 16K versions of CPM where every single byte mattered.
Thank you.
No problem. Other folks? Oh, go ahead, I'll take.
Go back to page 1 so I can get a picture of that.
Oh yeah, I think we can handle that. There you go. And we got one back there, did you?
I have two questions. One is, you mentioned the Model 1, Model 4. On the Model 3, is there a preferred?
I have not. I think actually someone is demoing a Model 3 with a remap board. Are they here? I don't see. Mike Lowen, yeah, I don't think he's here. So I think there will be an exhibit of that. I did not get anything to run on a Model 3. Any of the experts in the room, any recommendations on Model 3s? Nope. So, I think that's, Model 3 is tough. I think not only is the board very uncommon that Mike Lowen is doing, I don't think he's gotten anything to boot on it yet. So I think one of the goals that here is they're going to try and hook it up to a hard drive system and see if they can get the hard drive version of one of the CPMs to boot on the Model 3.
You mentioned also on the Model 1, if you didn't want to use a remapper, you had to have modified programs.
Correct.
So I think maybe two parts to that is there an archive of such programs? And if not, is there a tool that you can use to remap a program so that it would work?
The tool would be really hard. That does not exist that I'm aware of. And I don't think there's an archive. There's very little software. In fact, for the R32 baud program, by writing your own program, you could solve this. And in fact, it was kind of clever how they did it. At the top of the assembly language, they defined an E of like 4200 and then just like added to all the CPM addresses, so you could actually like just use defines to like move the stuff, but you really need the source code is kind of as far as I know, is the bottom line. So the answer is no. And that was the big drawback of that approach. Like you can't just load WordStar up and have it run, it wouldn't work. Any others? All right, I will finish up and we'll get on to our next program. Everybody welcome to Tandy Assembly, and thank you so much for your attention.